Hello everyone. On this video we will be looking at derivatives of natural exponents. Okay, so that means we're looking at the derivative of e to the power of x. And oddly enough, the derivative of e to the power of x is just e to the power of x. And the derivative of e to the power of a function of x is just e to the power of that function of x times the derivative of that function. Alright, so we'll do a quick proof of this first one. The second one isn't too far off. Okay, so what if we have the derivative with respect to x of e to the power of x? Okay, so like with any derivative, it goes right back to the limit function. Limit definition. So you have the limit of e to the x plus h, because remember it's f of x plus h minus f of x all over h. So you have e to the x plus h minus e to the x all over h as h approaches 0. Okay, now e to the x plus h, we can actually have that as two factors. So you have the limit as h approaches 0 of e to the x times e to the h minus e to the x all over h. Okay, so if we go ahead and factor out e to the power of x, we have the limit as h approaches 0 of e to the power of x times e to the power of h minus 1 all over h. Alright, so if you remember your properties or your limit laws, you can go ahead and just apply the limit to both of those factors. So you have the limit as h approaches 0 of e to the power of x times the limit as h approaches 0 e to the power of h minus 1 all over h. Alright, so for this first factor, you have the limit as h approaches 0. Using direct substitution, there's no h to be replaced. So this is just e to the power of x. And this one, if you actually plug in values of h as it gets closer and closer to 0, you'll see that the limit for this term here, or this factor, is actually equal to 1. So you end up with e to the power of x times 1, which is e to the power of x. Alright, so that is how we find the derivative of our natural exponent. Alright, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our examples. Alright, so let's say you want to find the derivative of f of x equals e to the power of 3x. Alright, so with this one, remember the derivative, I'll just put remember right above it. The derivative of e to the power of a function of x is equal to e to the power of that function of x times the derivative of that function. So that means the derivative of e to the power of 3x is going to equal e to the power of 3x times the derivative of that exponent. Alright, so that's going to equal e to the power of 3x times the derivative of 3x is just 3. So that gives you a derivative of 3 e to the power 3x. Alright, so it's pretty straightforward. Okay, let's move on to our next example. We have a little bit of room left on this page. No need to waste paper. So now, what if you want to find the derivative of f of x equals 5e to the power of 6x? Alright, so what I want you to do is I want you to go ahead and press pause and try to solve this one on your own using the same method up there. Alright, so I'm assuming you've pressed pause and worked this one out. So let's go ahead and verify your answer. So we have the derivative of 5e to the power of 6x. Now if you want to, you can go ahead and just bring that 5 right on out. So you can make that 5 times the derivative of e to the 6x. Okay, so that's going to equal 5 times the derivative of e, because remember, you're using this method up here. It's going to be e to the power of 6x times the derivative of that 6x. Okay, which is going to equal, you have 5 times e to the power of 6x times the derivative of 6x, which is just 6. Okay, so that will give you 5 times 6, which is 30. That's 30 times e to the power of 6x. Alright. So, if you are still writing, feel free to press pause. But we're going to go ahead and do another example, just to make sure you kind of see where the method is coming from. Alright, so let's say, for example, you want to find the derivative, h prime of x, if your h of x is equal to x to the negative 7th power plus e to the power of negative 8x. Alright, so let's go ahead and solve that. So, in order to find, let me write down, I'll just write down the original one first. X to the negative 7 plus e to the negative 8x. So to find your derivative, you want to find the derivative of each term. Alright, so we find the derivative of this first term, just bring down negative 7. So you have negative 7x, and we subtract 1, so that would be negative 7 minus 1, which would be negative 8, plus the derivative of e to the power of negative 8x is going to equal e to the power of negative 8x times the derivative of that negative 8x. Alright, so that's going to equal negative 7x to the negative 8 power plus e to the negative 8x times the derivative of negative 8x is just negative 8. So that is going to equal negative 7x to the negative 8 power minus 8, because you have that negative, I'll change that to minus 8e to the negative 8x. Or, if you want to, you can make it negative 7 over x to the power of 8 minus 8 over e to the power of 8x. Because remember, you have the negative exponents. You can just move them to the denominator. So either one of those will be true. All depends on how they want your answers on that particular problem. Alright, so hopefully this made sense, and I will see you on the next video.